So we're going to have the same set of directions, solve, graph on a number line, and write our answer as an interval, but our fractions are going to be in our problems. So let's say we have x plus 5 cubed times x minus 2 divided by x squared times x plus 1 is less than or equal to 0. Okay, we're going to do this problem really similarly to the way we did the polynomial inequalities. It's just one or two small differences. So for starters, when we're finding our boundary points, we have x plus 5 set equal to 0 and x minus 2 set equal to 0, but we'll also set the x squared and the x plus 1 equal to 0. So it would be all of the factors in the numerator and the denominator set equal to 0. So certainly have x equals negative 5 and x equals positive 2, but we also have x squared equals 0, so x equals 0, and x plus 1 equals 0, so x equals negative 1. Okay. The numbers from the denominator should make us very uncomfortable. We're setting denominators equal to 0. That should make us really uncomfortable. When we get to our answer, we should not be putting any brackets by numbers that came from setting the denominator equal to 0. I'll say that one more time. When we get to writing our answer, we should never put brackets around numbers that came from setting a denominator equal to 0. So let me write myself a little note for both of these. What I actually do is I put parentheses around them to remind myself. So only parentheses on numbers that came from setting the denominator equal to 0. Why? Because we can't divide by 0. So while x can be numbers close to 0 and close to negative 1, we can't allow x to actually equal 0 and negative 1. Therefore, only parentheses on those. Okay, I'll come back to this point when we write our answer. So we have our 4 boundary points. So let me scooch this up and write our sign chart for step number 2. All right, so we'll plot, let's see, negative 5 came first, then negative 1, then 0, and then 2. And each of these is going to get a column. Fabulous. Okay, so as we pick numbers and plug them in, I'm going to make a copy of what we're plugging them into. Move it over here. There we go. All right, and let's pick a number like negative 100 over here on the very far left. So when we plug negative 100 in, negative 100 plus 5 is definitely negative, and when we cube it, it will stay negative. Negative 100 minus 2 is certainly going to be negative. Doesn't matter what x is. Any number squared is always going to be a positive in our denominator. And negative 100 plus 1 is certainly negative. Since we have an odd number of negatives, a negative times a negative divided by a negative, it's going to stay negative. So definitely less than or equal to 0, which means we have true for our first column. Cool. Our first set of solutions. Now, I know that each one of you could take numbers in each column and plug them in and see whether you get a true statement or a false statement out. I would like to show you, if you want, a shortcut you don't have to use, but you can if you like. So let's go back and look at the exponents to see if our trues and falses are going to alternate or not. So instead of picking a number like, let's say, negative 3 in the next column, which would be perfectly okay, look at the x plus 5. So that was our negative 5 here, was our boundary point. It came from the x plus 5. which is important because the x plus 5 has an exponent of a 3, which is odd. So that will alternate true, false, because it has an odd exponent. Okay, so if it starts off true around the negative 5, because the exponent on the negative 5 is odd, it will turn to false. Likewise, for the negative 1, okay, so the negative 1 came from the x plus 1. It too has an odd exponent, so it should also alternate. So since it was false here, now around the negative 1, it should turn back to true. 0, however, came from having an even exponent. So the even exponent will not alternate. So if it was true on one side of 0, it will stay true on the other side of 0. And then finally, at x equals 2, the x equals 2 came from x minus 2, which had another odd exponent, so that should alternate and go back to false. But please know, if you don't remember that or that didn't make sense to you, plugging in numbers like negative 3 and negative 1/2, 1, and let's say 100 should give you the same true, false, false results. It'll just save you a little bit of time here. Okay, so let's go to writing our answer. Let me scooch this up and we'll write our solution. So our solution is always our true columns. So I'd like to have, let's see, this column on the far left and the two columns in the middle, negative 1 to 0 and 0 to 2. But I need to keep in mind my brackets and parentheses. Since the question had an equals to sign, I would like to put brackets. But I certainly don't want to put a bracket on an infinity. So here's what I want you to keep in mind. You always put parentheses on three things: infinities, negative infinities, and here's the tricky one, any number that came from setting the denominator equal to 0. So it doesn't matter what the question has in it, whether it wants brackets or not. If you have an infinity, put a parenthesis there. If you have a negative infinity, put a parenthesis there. And if you have a number that came from setting your denominator equal to 0, we cannot divide by 0, put a parenthesis on that number. So those numbers, remember, we marked up here, that was 0 and negative 1. So when I go to write my answer, negative infinity always gets a parenthesis. Negative 5, well, it's not an infinity and it didn't come from the denominator, so bracket. Union. Negative 1 should have a parenthesis because it came from the denominator, setting the denominator equal to 0, as does 0. So both negative 1 and 0 have parentheses, but 2 doesn't come from the denominator, so it can have a bracket. And like we talked about in the previous example, I can't combine the interval negative 1 to 0, union 0 to 2 into one interval because of the parentheses on the zeros here. So there's our answer. Negative infinity to negative 5 with a bracket at negative 5. Negative 1 to 0 with parentheses on both. And 0 to 2 with a parenthesis on 0 and a bracket on 2. Let's try one last problem. So for our last problem, let's solve the fraction 2x plus 3 over x plus 4 is less than or equal to 1. Now this one isn't more difficult than the previous problem, but there's a really common mistake that people make. They try to clear fractions, and they do that by multiplying both sides by x plus 4. The reason that I would not recommend doing that is I don't know what numbers x could be. So if x is a number like negative 200 and I multiply both sides by x plus 4, then my inequality sign would have to flip around. But if x is a number like even 0 plus 4 is positive, the inequality sign would not flip around. I don't know what x is. That's the whole problem. So I would have to have a case-by-case basis. So instead of clearing fractions, I want to get 0 on one side, just as if I were factoring. So 2x plus 3 over x plus 4 minus 1 is less than or equal to 0. And then I want to write it as one fraction, so multiply the negative 1 by x plus 4 over x plus 4. So here's what we get. We've got 2x plus 3 over x plus 4 minus x plus 4 over x plus 4 is less than or equal to 0. Let me scooch this up a bit. That's going to give me 2x plus 3 minus x minus 4, distributing that negative through, all over x plus 4 is less than or equal to 0. And combining my like terms, I've got x minus 1 over x plus 4 is less than or equal to 0. Great. Okay, so my boundary points. Now I can see them. X equals 1 and negative 4. And what I want to remember is, to put parentheses around whichever one came from the denominator when I go to write my answer. Because looking at this question, it has a less than or equal to. I want to put brackets, but I can't put bracket around the number that came from the denominator because I can't divide by 0. So I'm going to put parentheses around my negative 4 just as a reminder, even when I write my sign chart. So when I list negative 4 and 1, I'm even going to remind myself with parentheses here because I always forget that piece. And then create my columns. Great. Okay, picking the first number, let's pick negative 10. So plugging in x equals negative 10, negative 10 minus 1 is negative, and negative 10 plus 4 is also negative. I have a negative divided by a negative, which is a positive, is not less than or equal to 0, so that's false. Okay, I notice, by the way, that I have only odd exponents on both the x plus 4 and the x minus 1. So I know that everything is going to alternate. So the next column should be true, which I could verify by plugging in, 0 between negative 4 and 1. And the last column should alternate also. So if I plugged in 10, I should get false. But again, I don't have to do that arithmetic. I can just look at the exponents. Okay, I always want the true column. In this case, there's just one of them. So I want the column here in the middle between negative 4 and 1. And I'd love to just write negative 4 to 1 with brackets because of the less than or equal to part. But remember, I have to have parentheses around the negative 4 because if x were to equal negative 4, I'd be dividing by 0, which is not okay. So I'm going to erase the parentheses around the negative 4, but not the negative itself, and erase the bracket and put parentheses around. So my answer is negative 4 to 1 with a parenthesis at negative 4, but a bracket at 1.